Good morning students. What was learned in the previous class? That is electric current, potential difference, resistivity, resistors and various Ohm's law, and then resistivity and conductivity all are discussed in the previous session. In the today's session we are discussing about the resistors and heating effect of current. Resistors already I explained in the previous class what are the various form of resistance. Resistant box, carbon resistors, all the form of resistors will be connected in series and parallel. How to calculate effective resistance? Okay. So first, resistor connected in series. What's the way the resistor will be connected in series? Series means resistor connected in series. One resistor, taking one resistor. Okay. The second terminal of the first resistor will be connected to the first terminal of the second resistor. And second term of the second resistor will be connected to the first term of the third resistor. That is called series connection. Okay. So three resistors R1, R2, R3, R1, R2, R3. Three resistors will be connected in series. Okay. Series means one connect பண்றது. இது வந்து battery. Okay. Voltage, positive and negative. Then three resistors will be connected in series. The effective resistance, how to weigh, what's the way to be calculated? So first, according to Ohm's law, V is equal to IR. Okay. In three resistors connect ஆகும்போது current it will be same. Current will be flowing through the three resistors, it will be same. Okay. But voltage will be differ from one resistor to another one resistor. So voltage V1 in the first resistor, voltage V2 in the second resistor, voltage V3 in the third resistor. Okay. V1, V2, V3 it will be changed. The voltage is developed across the three resistors, it will be changed. So current is same but voltage it will be differ. Current same, voltage it will be differ. Voltage differ. So V is equal to IR. So V1, V2, V3 we have to calculate. V1 is equal to current not same, not different. So I into R1. V2 is equal to I into R2. And V3 is equal to I into R3. Because resistor only change, current does not change. So V1, V2, V3. Substitute this and then total voltage V is equal to voltage change in the throughout the conductor. So voltage, total voltage V is equal to V1 plus V2 plus V3. Sum of the voltage in the three resistors. Voltage is definitely dropped between the three resistors R1, R2, R3. So voltage V is equal to V1 plus V2 plus V3. Substitute all the values. V is equal to IR and V1 is equal to I into R1. V2 is equal to I into R2 and V3 is equal to I into R3. Okay. So IR is equal to IR1, IR2, IR3. Then taking I as the common, I at the common, R1 plus R2 plus R3. Okay. So I cancel both the sides. R it will be equal to R1 plus R2 plus R3. This is the effective resistance or equivalent resistance. Three resistors, when the three resistors will be connected in series. Three resistors series connect panningena adoda effective resistance Rs is equal to R1 plus R2 plus R3. So equivalent resistance when the resistors will be connected in series, it will be equal to the sum of the individual resistors. Okay. So Rs is equal to R1 plus R2 plus R3. Three series connect panninga அப்படினா three resistance la போகக்கூடிய current same, voltage different. So அதுக்கான formula எழுதிட்டு voltage according to the Ohm's law V is equal to IR. So IR1, IR2, IR3 ன்னு எழுதிட்டு எல்லாத்தையும் substitute பண்ணி calculate பண்ணிக்கங்க. Okay. Then three resistors will be connected in parallel. One and another one and another one. Three resistors will be connected in parallel. Okay. R1, R2, R3. Parallel means parabolic. Parallel means not a parabolic. Parallel means once one end to be connected in series, another one end will be connected in series. ரெண்டு சைட்லேயும் ஒன்று போல் இந்த ரெண்டுக்கும் உங்களுக்கு வித்தியாசம் தெரியுதா? கண்டினியூவாக கனெக்ட் பண்ணியிருப்பாங்க. இங்கே 1 to 1 it will be connected. So it will be parallelly connected. So this is the way the current will be flowing. It will be different from one to another one resistor. That the current will be flowing in I1, I2 and I3. Okay. The current will be travel in the three lines. It will be divided into three segments, that I1, I2, I3. But the voltage does not same. Does not different. So voltage same, but current it will be differ. Okay. Voltage same, but current will be differ. So current will be calculated according to the Ohm's law. V is equal to IR. So I is equal to V by R. Okay. So I1 is equal to V by R. I1 is equal to V by R1 because voltage does not change. I2 is equal to V by R2 and I3 is equal to V by R3. Okay. Because all the terms V it will be same. Resistance only differ R1, R2, R3. Then total current I is equal to I1 plus I2 plus I3. So substitute all the values. I is equal to V by R. So V by R. I1 is equal to V by R1 and I2 is equal to V by R2 and I3 is equal to V by R3. Okay. So taking V at the outside, V 1 by R1, 1 by R2, 1 by R3. Okay. So this is V by R. V both side cancel. So 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. This is the effective capacitance when the resistor will be connected in parallel. 3 resistors in parallel connect panningina, the total equivalent resistance, reciprocal of the equal resistance will be equal to the sum of the reciprocal of the individual resistance. Okay. So what's the way we calculate? Two part is there. This part current same, V different. This part V same, current different. So according to both the phenomena, the Ohm's law only used. Ohm's law it will be explained. V is equal to IR. This is the way the V1, V2, V3 calculate. This circuit current I1, I2, I3 it will be differ. So we calculated by using the Ohm's law I1, I2, I3. We substitute the I1, I2, I3 values and then we calculate the total current value. So V by R is equal to V into 1 by R1 plus 1 by R2, 1 by R3, V cancel. So 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. இந்த ரெண்டுல என்ன டிஃபரன்ஸ், சீரிஸ்லையும் பேரலுக்கும் என்ன டிஃபரன்ஸ் அப்படின்னா, இன் சீரிஸ் கனெக்ஷன் effective resistance it will be the sum of all the individual resistance. In the parallel connection it will be reciprocal of the individual resistance. Then second one, series connection we calculate the equivalent resistance, it will be very much higher than the individual resistance. Individual resistance எந்த வேல்யூ ஹையாக இருந்தாலும் சரி அதை விட இதோட வேல்யூ ஹையாக இருக்கும். ஏன் எல்லாத்தையும் ஆட் பண்ணி கிடைக்கக்கூடிய ரெசிஸ்டன்ஸ். ஸோ த ஈக்குவல் ரெசிஸ்டன்ஸ் ஆல்வேஸ் கிரேட்டர் than the individual resistance. இங்கே equivalent resistance will be always less than the individual resistance. Suppose if the resistance will be very low, ஒரு resistance இதில் லோவாக இருந்தால் கூட பரவாயில்ல, அந்த லோவை விட இது லோவாக இருக்கும் effective resistance. This is the second one. And then third one, suppose one resistor it will be close, 3 resistor, not a 3 resistor, some 3 electronic appliances will be connected in series. One appliance it will be off, all the appliances will be in off, it will be is not working. Okay, do not any work. ஒரு நீங்கள் சீரியஸாக எல்லா அப்ளைன்ஸும் கனெக்ட் பண்ணுறீங்கன்னா ஒன்று ஆஃப் பண்ணோன்னே ஆட்டோமேட்டிக்காக எல்லாமே ஆஃப் ஆயிரும். இப்போ இதில் வந்து நீங்கள் இதை எடுத்துட்டீங்க அப்படின்னா இங்கேருந்து இங்கே கரண்ட் ஃப்ளோ ஆகாது. ஸோ all the appliances is not working now. But you should connect the 3 appliances, it will be in a parallel. Suppose the current it will be not falling on one appliances, another 2 appliances does not stop their work, it will be easily to continue their work. Okay, சீரியஸாக கனெக்ட் பண்ணிங்கன்னா ஒன்று ஆஃப் பண்ணோன்னே எல்லாமே ஆஃப் ஆயிடும். பேரல்னா ஒன்று ஆஃப் பண்ணாலும் பரவாயில்ல, எல்லா எலக்ட்ரானிக் அப்ளையன்சஸும் ஒர்க் ஆகும். ஸோ இதான் பேரல் காம்பினேஷன்ஸ். ஸோ ரெண்டுக்குள்ள டிஃப்ரென்ஸும் இதுதான். ஓகே, ஸோ வாட் ஆர் த டிஃப்ரென்ஸ் பிட்வீன் த சீரிஸ் அண்ட் பேரல் காம்பினேஷன்? It will be very much greater. That's a effective capacity, it will be very much low, and one it will be switched off on all the appliances, it will be not to be function, but one will be switched off and another to work. Okay, that is the difference between the two. Then now we calculate the series connection of parallel resistance and parallel connection of series resistance. Another 2 electric circuits I explained. Series connection of parallel resistors. This is the parallel resistor, this is the parallel resistor. 2 resistors will be connected in parallel, 2 resistors will be connected in parallel. So okay, R1, R2, 2 resistors will be connected in parallel. R3 and R4, 2 resistors will be connected in parallel. Okay, but that the parallel resistance will be connected in series. What's the way, ma? First, we calculate the R1, R2, it will be connected in parallel. R1, R2, it will be connected in parallel, okay? And R3 and R4 are connected in parallel. So, effective resistance is 1 by Rs1 is equal to 1 by R1 plus 1 by R2. Parallel combination means 1 by R1 plus 1 by R2. Then, this is the way 1 by Rs2 is equal to 1 by R3 plus 1 by R4. Okay. So, how to calculate, ma? 1 by Rs1 is equal to R1, R2. R2 plus R1, taking the LCM. R1, R1 by R1, R2. Then, Rs1 is equal to R1, R2 by R1 plus R2. ரெண்டு parallel எடுத்துக்கிட்டிங்கன்னா 1 by Rs1 is equal to 1 by R1 plus 1 by Rs1 ஏன் எடுத்துருக்கோம்? இது ரெண்டும் parallel இருக்குது, இது ரெண்டு parallel, sorry, Rs1 இல்லை, RP1 parallel combination, RP1 parallel, so RP1 will be connected in RP1, RP1 parallel connection 1, parallel connection 2, parallel connection 1, RP1 is equal to R1, R2 plus R1 plus R2, then RP2, so 1 by RP2, the parallel connection 2, that is R4 plus R3, taking LCM, R4 plus R3 by R3 into R4, okay. So, RP2 is equal to R3 R4 by R3 plus R4. This is the parallel connection 2. The parallel connection 1 is parallel connection 2. Then you have to sum the two parallel connections. These are parallel, okay. Now the circuit will be changed. RP1 and RP2 in the battery connection. This is the series connection of parallel resistors. ரெண்டு parallel, இது வந்து parallel connection 1, இது parallel connection 1, இது parallel connection 2. ரெண்டே parallel connect பண்ணி we calculate the series connection of 2, that is RP1 and RP2. RP1 to be connected in parallel, sorry, series. So, effective resistance Rs is equal to RP1 plus RP2. Okay. Substitute the RP1 value, R1, R2 by R1 plus R2. Okay. Then plus R3, R4 by R3 plus R4. This is the series connection of parallel resistors. So, parallel combination resistor is there in the circuit. First, you should solute that the parallel resistor to calculate the effective resistance when the resistor will be connected in parallel. So, two parallel resistors will be calculated after the parallel resistor will be making a series resistors, and then after you have to calculate the effective resistance when the resistor will be connected in series, we easily find out. Okay. Now, the series connection of parallel capacitors, parallel resistors. Series connection of parallel resistors. Parallel connection of series resistors. Parallel connection of series resistor means that is R1, R2, okay. That is R3 and R4. R1, R2 is connected in series. R3 and R4 connected in series, okay. R1, R2 series, okay. Then R3 and R4 series. R1, R3 is series, R3, R4 is series. So, now series mean Rs1 is equal to R1 plus R2 and Rs2 is equal to R3 plus R4, okay. Okay. Then, now the circuit will be becomes Rs1, Rs2 and battery. So, Rs1 and Rs2 and battery. So, now the circuit will be changed into the parallel connection. So, Rs1, Rs2 it will be connected in parallel. So, 1 by Rp is equal to 1 by Rs1 plus 1 by Rs2. Okay. This is the parallel connection of series resistors. இங்கே 2 சீரிஸ் ரெசிஸ்டர், இங்கே சீரிஸ் ரெசிஸ்டர் கொடுத்துருக்காங்க அப்படின்னா ஃபர்ஸ்ட் சீரிஸை கால்குலேட் பண்ணிக்கிட்டு அப்புறம் அது பேரலல் ஆக்கி கால்குலேட் பண்ணணும். நவ் RS2 plus RS1 by RS1 into RS2. Then இது 1 by RP. So RP is equal to RS1 RS2 by RS1 plus RS2. This is the way we calculate the easily when the resistor will be connected in series first and then all the resistors will be connected in parallel. This is the way we solve. First the resistor will be connected in parallel, after all the resistors will be connected in series. This is the way you have to solve that. Okay, so in our book I am having some problems recording this formulas. Okay, recording this circuits. The circuits are used பண்ணி bookல நிறைய problems இருக்கு. Okay, and now we have explained the heating effect of current. So resistors are over. Now we explain the heating effect of current. Heating effect of current is nothing but you have to apply the current. Keenly observe the bulb. Okay, the bulb, how the way the bulb will be glowing. One tungsten filament is there. The tungsten filament will be heat. We applying the energy, the tungsten filament to be heat to create the light glowness. Okay, so heating effect of current means the current it will be applied on any one filament. The filament it will be heat after giving the energy. Okay, so bulb will be glowing. You have to apply the heat energy. That the heat energy it will be used to work. One part of the energy it will be used to convert the energy. Another one part it will be used to liberate waste of energy. ஒரு பார்ட் வந்து அது ஒர்க்காக யூஸ் ஆகுது, இன்னொரு பார்ட் வந்து ஹீட் எனர்ஜியாக லாஸ் ஆகுது. Evenly you have to touch the any electronic appliances all the time, continuously the electronic appliances will be working. After working, long time working, we touch the mobile or we touch the electronic appliances, you have to feel the heat. Okay, ரொம்ப நேரம் ஒரு எலக்ட்ரானிக் அப்ளைன்ஸ் வந்து ஒர்க் ஆகிட்டே இருக்குதுன்னு பார்த்தீங்கன்னா அப்படின்னா அது வந்து ஹீட் ஆயிரும். நீங்களே டச் பண்ணி பார்த்தீங்கன்னா தெரியும். So some of the current, some part of the energy it will be lose the heat energy. Okay, what the way the work, one part of the energy it will be used to work the anyone thing. So work, how will you calculate the heat energy? Heat energy H is equal to work is equal to V into Q. Okay, work done, the heat energy will be used to create used to work anything. So heat energy it will be work is equal to, the formula is V into Q. So according to Ohm's law, V is equal to IR, but Q is equal to, current I is equal to Q by T. Okay, but Q is equal to I into T. Substitute the two values in this equation. H is equal to, V is equal to IR, so IR, Q is equal to I into T. So I, 2I is there, so I square R into T. This is the heat energy formula. So the heat energy will be liberated is the one system. Our heat energy will be used to convert a work in the any one electronic appliances. H is equal to I square RT. This is called Joule's law of heating. Okay, so ஏதாவது ஒரு எலக்ட்ரானிக் அப்ளைன்சஸ் இருக்குது அப்படின்னா நீங்கள் அதில் வந்து நீங்கள் கரண்ட்டை அப்ளை பண்ணும்போது அது சம் அமௌண்ட் ஆஃப் ஹீட் எனர்ஜியாக லாஸ் ஆகும். That the heat energy is equal to I square RT. I is the current, R is the resistance and T is the time. This is called Joule's law of heating. So Joule's law of heating, the amount of heat energy H is equal to I square RT. So heat energy will be directly proportional to the square of the current. Heat energy will be directly proportional to the resistance. Heat energy will be directly proportional to the time. This is called Joule's law of heating. So heat energy will be completely depends upon the current, resistance and time. Okay, so Joule's law of heating, heat energy is equal to I square RT. Here heat energy will be directly proportional to the current, square of the current. Heat energy will be directly proportional to the resistance. Heat energy will be directly proportional to the time. So this is called Joule's law of heating. And then applications of heating effect of current. This is just the 3 points. Applications of heating effect of current, just application of Joule's law of heating. One is electric heating devices. Electric heating devices. Many electric devices there. We apply the current, the heat instruments it will be working. That is a haze or iron box, and then electric heater, then more and more toaster, pan, all the things current will be apply on the one electronic appliances that the heating devices will be working. Okay, especially iron box, the heat energy it will be working. That is iron box having we supply the current, one element is there, that the element is nichrome. Nichrome is the alloy of nickel and chromium. Nichrome is the alloy of nickel and chromium. Nichrome having the high resistivity and then high melting point. That the melting point in the high. Okay, so easily cannot melt. So nichrome having the high melting point. So continuously the instrument it will be working. The element in the iron box it will be burn, and then melting point it will be high. So easily melt. So melting point it will be high. Okay, so nichrome it will be used in the iron box. Okay, melting point it will be high and a high resistivity and cannot be easily oxidized. ஈஸியாக நீங்கள் வந்து ஹீட் பண்ணிகிட்டே இருக்கீங்க, அதனால் வேப்பரைஸ் ஆகி கேஸாக போயிடாது. ஸோ cannot be easily oxidized. So high melting point, high resistivity and high cannot be easily oxidized. That the good character for nichrome it will be used in the various heating devices. So electric heating devices having the nichrome, okay, nickel and chromium as alloy of nickel and chromium. Nichrome having the high melting point, high resistivity and cannot be easily oxidized. So this is a good behavior. Nichrome it will be always used in all the heating devices, okay, especially iron box. And then second one, fuse wire. All the electric board are having fuse wire. Fuse wire will be connected between the two terminals of the one ceramic plate. இங்கே ஒரு டெர்மினல் இருக்கும், இங்கே ஒரு டெர்மினல் இருக்கும். இதில் வந்து ஒரு wire வந்து கனெக்ட் பண்ணியிருப்பாங்க. That is fuse wire. Fuse wire is alloy of tin and lead. Okay, fuse wire. What's the use of fuse wire, ma? In our home, all the electric board are having the fuse wire. What's the use? The fuse does not having our home fuse wire. The current it will be continuously supplied on all the electronic appliances. Suppose high much of current it will be flowing in our home, easily damage all the electronic appliances. Suppose in our home having the fuse wire, normally 220 volt ohm we supply by the electric board, but sometimes 400 ohm near the current will be supplied in our home. That of 400 ohm does not tolerate all the electronic appliances. That of 400 ohm voltage it will be not a ohm voltage, it will be applied on the fuse wire. The fuse wire to be melt and then discontinue the electric conductivity to all the electronic appliances. Fuse wire work என்ன அப்படின்னா, fuse carrier நம்ம வீட்டில் ஒன்று இருக்கும். சப்போஸ் கரண்ட் நமக்கு வந்து வரல அப்படின்னா ஃபியூஸ் போயிருக்கும் அப்படின்னு நீங்கள் சொல்வீங்க, கேள்விப்பட்டிருக்கீங்களா? அதோட மீனிங் என்ன அப்படின்னா, ஃபியூஸ் வயருங்கிறது ஒரு ஒன் ஹோல்டு செராமிக் கோட்டு, அதில் நடுவில் ஒரு ஸ்ட்ரிங் இருக்கும். சப்போஸ் ஹை மச்சாக கரண்ட் 220 வோல்ட் தான் நமக்கு வீட்டுக்கு சப்ளை ஆகணும். சப்போஸ் 400 வோல்ட் சப்ளை ஆகுதுன்னு வச்சுக்கோங்களேன், ஹை கரண்ட் ஃபாலோ ஆகுது. அந்த ஹை கரண்ட் ஃபாலோ ஆகும்போது ஃபியூஸ் வயர் வழியாக போகும்போது ஃபியூஸ் வயர் என்ன செய்யும், பிரேக்கப் ஆயிரும், பேர்ன் ஆகி பிரேக்கப் ஆயிரும். பிரேக்கப் ஆனால் இதோட கண்டினியூவாக நீங்கள் என்னென்ன கனெக்ஷன்ஸ் கொடுத்துருக்கீங்களோ அதில் எல்லாத்துலேயுமே கரண்ட் ஃப்ளோ ஆகாது. அது வந்து ஏன் நம்ம ஃபியூஸ் வயர் போடுறோம், சப்போஸ் ஃபியூஸ் வயர் இல்லைன்னு வச்சுக்கோங்களேன், ஹை மச் ஆஃப் கரண்ட் இல் பி ஃபாலோயிங் டு த ஆல் த எலக்ட்ரானிக் அப்ளைன்சஸ், ஃப்ரிட்ஜ், வாஷிங் மிஷின், டிவி, ஆல் த தட். எல்லா எக்ஸ்மெண்ட்டுக்கும் நம்ம போகும்போது எல்லா எக்ஸ்மெண்ட்டும் என்ன செய்யும், டெஃபினெட்லி பிரேக் ஆகும். ஸோ ஃபியூஸ் வயர் இருந்துச்சுன்னா நமக்கு வந்து ப்ரிடிக்ட் பண்ணிடும், கரண்ட்டை வந்து எல்லா இடத்துலையும் இப்போ சப்ளை ஆகாமல் தடுத்துடும். ஸோ ஃபியூஸ் வயரோட ஒன் பர்பஸ், இட் வில் பி டஸ் நாட் அலோவ் த ஹை மச் ஆஃப் கரண்ட் டு அவர் ஹோம். ஓகே, ஸோ த ஃபியூஸ் வயர் வில் பி using on the basis of heating effect. The current will be high much of current, it will be applied the fuse wire to be melt. So fuse wire always having the high melting point. So high melting point, so definitely does not melt easily. So high melting point having the fuse wire will be completely protect our home by the passage of high amount of electric current. And third one, heating filament. What's the meaning that filament, ma? Filament is nothing but taking the bulb, okay, bulb, bulb having one okay, this is filament tungsten. You have to switch on the bulb. The tungsten in the bulb, it will be burn and it will be create the glowness. Okay, பல்பில் சென்டரில் ஒரு ஸ்ட்ரிங் மாதிரி இருக்கும். அந்த ஸ்ட்ரிங் என்ன செய்யும், ஃபஸ்ட்டு பேர்ன் ஆகும். பேர்ன் ஆகும்போது என்ன செய்யும், அதனால் அந்த பிரைட்னஸ்னால அந்த லைட் வந்து க்ளோ ஆகும். இதில் இருக்கக்கூடிய இன்னர் கேஸஸ் வழியாக அந்த லைட் டிரான்ஸ்மிட் ஆகி உனக்கு லைட் க்ளோ ஆகும். ஸோ டங்ஸ்டன் இஸ் அ வெரி குட் ஃபிலமெண்ட் having the high melting point. It will be used to the heating electric devices. So the filament will be always fixed in the light. So the filament first, when the current it will be applied on the bulb, filament it will be first hot and it will be burn, that burn, and then it will be create the glowness. So the tungsten will be always using the filament in the bulb. So tungsten is always also having the high melting point. So high melting point இருக்கனால ஈஸியாக மெல்ட் ஆகாது. ஸோ இந்த த்ரீலையுமே என்ன ஆகுதுன்னா, இங்கே கரண்ட் அப்ளை பண்ணுறதுனால when the current it will be applying on the devices, the device it will be burn and then heat energy it will be supplied, that the heat energy will be converted into the it will be used into the some work. Okay, so nichrome it will be used in the heating devices, and fuse wires is the alloy of tin and lead will be used in the fuse wire, and filament tungsten will be used. The three electronic device, the heating devices are having the high melting point and low resistivity, high resistivity, and then that's not easily oxidized. So that is the applications of Joule's law of heating. So in this session we have discussed about the resistor contained in series and parallel, how to calculate the effective resistance when the resistor will be contained in series and parallel, and then series connection of parallel resistors, parallel connection of series, all are calculate the effective resistance. And then what's the heating effect of current, what are the application of heating effect of current also we had discussed. Then home assignment for today's session. Home assignment. Learn and write the effective resistance or equivalent resistance. Anything is safe, say equivalent resistance. When the resistors connected in series and parallel. When the resistors are connected in series and parallel. So resistor connected in series and parallel, you have to calculate the equivalent resistance. So learn and write the equivalent resistance when the resistor will be connected in series and parallel. Okay, thank you.